Sorry for the confusion and the quick change. I'm late because I was sitting over in a session that was scheduled to happen today, but then got swapped, and Wayne was going tomorrow morning, and Dave Boucher was going today, but they've swapped. So here we are, and hopefully the folks that I left a note with the folks that are in the other session to come join over here. So hopefully we'll see them join. Welcome everybody. My name's Jeff Blair. I'm the manager of the SaltStack team here, and Wayne Werner is one of our experienced and senior Salt developers who has a deep passion for testing and test automation. And so since we're already 3 minutes in, Wayne, I'll hand it over. I have one question. Do you want folks to lob their questions throughout your discussion, or do you want to save them for the end?
Yeah, you can go ahead and throw them out as we're going through. This is going to be probably much more interactive than a typical talk is my goal for it. So, yeah.
Okay, so my ask then is, folks, if you want to ask your question verbally, go ahead and request to share your screen and your video, and we can do that. If you prefer to just put them in the Q&A tab, go ahead and do that, and then we'll address them as they pop in. So with that said, I'll hand it over to you, Wayne.
All righty. So here we go. So this is going to be very much a introductory talk. So if you are new to testing and development in Salt, this is for you. If you have been testing a whole bunch, it probably won't surprise you, but you might find something informative. So, yeah, to Peter's point, it's a test clinic, pretty much. So, the best way to get started, if you haven't, is head over to the documentation here at docs.saltproject.io, and then in the table of contents here, I just search for contributing, and that will get you to the contributing guide, which has a rather comprehensive but not quite perfect, as I discovered over the past couple of days practicing this, but a comprehensive guide for getting your environment set up. So I'm going to kind of try and do this live. We're going to see exactly what happens. Obviously, my own system is completely set up and configured the way I want it for development. You may not have that same experience. So using Vagrant here on the left, you'll see that I'm creating this image based on Ubuntu Jammy 64. And I've got a couple of different, I have one that's mostly configured already, but then this one that is not. So we'll see how fast it goes. Some of these parts are going to take a long time because they're doing things like downloading a bunch of stuff and building a bunch of stuff. So if you're doing this on your own, you're probably going to want to go grab a sandwich or take a little walk around the block, whatever. Some of the things can take some time. Some of them much more than others, especially if you are going to clone the entire repository in one fell swoop. So our Vagrant box here is cloned or spun up. So you should be able to SSH into it. Yeah, time 4 hours later. Yes. So going through this documentation, I'm not going to read it all to you. Just suffice it to say that you can kind of follow along. Most of this should be copy pastable. And it should, quote unquote, just work. I did discover some slight issues with virtual end in it and how and adding that stuff to the bash RC, but we're gonna give it the old college try. while we're waiting for that, let me jump into this other box, because as you can see, it's taken a minute to clone this PiInit repo. Curse my Windows environment. You can develop on Windows, but it's difficult, and I would say kind of an advanced.
Might I suggest the Linux subsystem for Windows?
Yes, that would make it much easier, but it is possible at least. So here's the bit where kind of things went sideways for me. Let's see. Yeah, we're still gonna wait for that a little bit. So on this other container, I actually have this stuff in my bash RC here. So I've got, I wonder if that double dot there might have something to do with it. Anyways, so this is the output of these commands. So PiInit, and oh yeah, there we go. PiInit dash. That's actually missing from the instructions here, and I think they changed it from standard air, because it was on standard air when I created this before. Anyways, and then also virtual env init, and it looks like that as well. So that produces, that actually might be why it didn't work for me when I was activating some environments. So cool. Let's give that a try. So let's go ahead and export our PiInv into our bash RC, and let's try this. PiInv init bash RC and PiInv virtual env init bash RC. Okay. That looks much better than this other bash RC. That is probably why when I was activating my virtual env, it just flat out did not work the way I expected it to. So I'm going to go ahead and, rather than install 3.7, I'm going to install 3.9.0. And it's actually going to fail here in a minute because I don't have like anything installed. In the documentation for PiInv, you've got a suggested build environment. And as we are on Ubuntu, where'd you go? There you are. We want this, but there's actually one more that I have. Get the is, yeah, libcurl. It's not for the a requirement for building. Oh my. That's not a requirement for building with the PiInv. It ends out being important later on. Yeah, we want to go ahead and use all that. And all right. So let's see. Yeah, Sigwin would definitely be an option under Windows. Thomas Phipps started using Ascent VM and OpenStack and Debian 10 VM for different distros. Hoping to use Salt for provisioning / managing Windows. So you can, Salt Minion, you can run that on Windows. We have Chocolatey, and I think there's something else, or maybe we were starting to, or looking at supporting the new Windows like package manager deal, the WinRepo. Yeah, so we are looking at doing a lot of that stuff. Oh, Winget. Yeah, I think that was it. So yeah, definitely have support for managing Windows with Salt. But yeah. So definitely go check that out if that's something that you need and are interested in. So still building a whole bunch of stuff. Actually, let me edit my bash RC here to see if I can do this correctly and get things to work without having to do some hocus pocus. If you're not familiar with Python virtual environments, then you can quickly find yourself in an XKCD worthy scenario.
I was just telling my kids about the XKCD where the guy was bragging about how secure his password was, and the guy pulled out a $20 wrench to beat him with it until he told him his password.
Yep. Cool. So in our fancy environment here, we actually have got our PiInit installed. So I'm impressed. It seems to be going much faster, probably because I switched to a hardwired connection instead of my Wi-Fi. So we'll see if this actually continues on. So in our one that I just spun up here, virtual env 3.9.0, and we're going to call it Salt. So pretty sure it just installed that. So all right, PiInit. Versions. Okay. Oh, because I downloaded it, I installed all of the dependencies, not this actual Python 3.90. Right. I'm picking up what I'm putting down. Yeah, there is always a relevant XKCD. PiInit takes some time to understand it. Yeah, it's tricky because PiInit is really powerful, but you start throwing virtual environments, different environments, generally speaking. You start throwing Linux paths in there, and you just there's so much expertise to know what's happening and when it goes wrong, why. So your mileage may vary, but PiInit, generally speaking, should have, like, the best thing about it is it allows you to provide multiple different versions of Python on your system for testing with, which can be a very good thing. So we are...
And not having your dev packages installed in your global environment.
Yes. So I take it PiEnv is different than for venv/virtualenv. Yes. PiEnv is to Python as virtualenv is to environments. Basically, it allows you to install multiple different versions of Python on your system, and then you can use any one of those Python versions to create virtual environments from it. So it can be super handy, but then you get into this nesting doll thing where it's like, oh, you've got a PiEnv, and then you've got a bunch of virtual envs inside each of these PiEnvs, and you've got to activate it correctly and stuff. If you've been following the test clinic for the last month or so, something went completely sideways with my PiEnv installation, and I think it might be this pathing issue. And so I've actually just taken to manually activating my version of Python that PiEnv installed. So yeah, it is a complex beast, to say the least. But let's try this then. So in theory, in my activate salt. Nope, it did not fix it. I'm curious to see what happens in this other environment as that Python finishes building and installing. So basically what we have here is so PiEnv puts all of its versions in this .pyenv directory. Inside of its shims directory, it has a bunch of scripts and things that you have installed into your environments. But the relevant place for us is in this versions. So it actually has this 3.90 version of Python, and then this salt. It actually looks like a symlink to, oh, there you go. It's actually a symlink to versions 3.9.0/envs /salt. So what I just do is I do a source, because it actually does build a proper virtual env for these. And so this is where knowing PiEnv, virtual env, all this stuff kind of gets to be, like, it's useful. Because if you don't know what's happening here, it's all very confusing and hand wavy, and you're just like, I don't know, something happened. So I like to have guides that give us as much like, just do this and you'll be fine as possible. But sometimes you kind of have to have that knowledge to figure out what's going on there. So here, something is failing to set path variables correctly. So I can source this directly with PiEnv, versions, salt, bin, activate. And now you can see my prompt change. So yes, magic. So now I have the Python command, and which Python will tell you where this Python lives. That's the important thing to note when you're dealing with virtual environments, is that which Python will tell you which Python that you're using, and you want it to be pointing to the environment that you care about. And then if that is the case, then this Python will always execute in that particular environment. There's some strange magic you could do with like changing your path and your Python path environment variables, but generally speaking, Python-m is much more reliable than trying to run pip, because that pip could break and point to your system pip or something else. So, but when you've got a virtual environment active and you know which Python you're using, then Python-m will always do what you expected it to be able to do. So now let's create that and see if there was something that happened. So it did finally install that, which is good. I feel like it took way longer the other day, but maybe just exercised its paths on my hard drive or something. I don't know. Oh, right. So that might be why it didn't work in my other one. I hadn't actually changed it. Which Python? Oh, yeah. Okay, cool. Well, we are in this environment, roughly where we are here. Oh, that's right. I did install some salt. So let's go ahead and do this. This is a pretty good option to take, unless you already have salt cloned, because this takes like, I don't know, that was maybe 30 seconds. If you had tried to do that with the entire salt, there's over 108,000 commits to salt, which is 108,000 more than I just downloaded. It takes a while is what I'm saying. I think it took me like 30 minutes to download that whole thing. Yeah. I'm going to skip adding this, but I am going to go ahead and get into this part. So this is actually where we would have failed without libcurl. So we're going to do a Python-m install, pre-commit, and Nox. But we are going to deactivate first. But first, we're going to source PyN versions, salt, then activate. All right. Now we're going to install commit and Nox. And so this time we're sure that it's actually going to their, I guess, oh wait, yeah, now I have a pip in here, but it could have been pointed somewhere completely different. But it was not. So now cd to salt. I'm going to skip the image magic bit because that is just for docs, and at least for now, not going to worry about building the documentation or anything. There's a lot of stuff there, but we are going to go ahead and install salt in editable mode. So pip install -e and then dot, and it's the current directory. And we'll let that, while we're letting that do its thing, we'll jump down here to our first test command. So what we want is Python-m Nox. So that says, hey, the Nox that we're running is the one that was installed in this Python and not some other Nox. We don't need 3.7 here, just pytest-3. And we're going to run this test/unit/cli/test batch. It helps if we actually run within the salt directory. And it will go ahead and you'll notice here it says reusing virtual env. And it's going to say, oh yeah, we've already installed a bunch of stuff. And we should be able to run this same command. Here. And this time, this one will actually take a significant amount of time because you'll see it's creating a virtual environment. It's actually going to be installing a bunch of dependencies, whereas those were already installed. Now, you may notice that this said it only took 0.99 seconds to run those, but that was much longer to run that command. I think it was almost a minute. So there is actually a nice handy command that you can use to make that go faster. And I will show that to you after we finish this run here and get it to do its thing. So there you go. 30 seconds for that to run, as opposed to 1 second. So that is because it's trying to do all those installations. So that what's actually doing is looking and saying, oh yeah, already installed, already installed, already installed, already installed, which takes a little while. So you can, once you have Salt installed in your particular test environment, and each different invocation of Nox, each little environment here will create a virtual environment. So this is where I started talking about the nesting dolls, right? So we have PiEnv, which has created our Python 3.9, and then we have our Salt virtual env inside of there. And then Nox has created a virtual env for this PyTest 3, in particular, PyTest 3 coverage equals false. And I think that's as far as it goes here, but you can start to see where things can go very complicated very quickly if you're not paying attention. So what you need here is just an environment variable, and it is skip requirements install. So if we do an export skip requirements install, and now we rerun this, you'll see right here, skipping because skip requirements install was found in the environ. And 5 seconds to run that whole thing instead of 30. So a significant speed up to that. You can see this is still not done installing the Linux dependencies. It'll probably take another several minutes. So, you know, it's doing its thing. But what we have here is, hey, we can actually run a test, you know, which is good because that's where we want to be. In order to write some tests, we want to be able to run the tests. So if we if you want, like if you have something in mind, you know, oh, I've got this feature or I've got this bug fix that I want to solve, then great, use that. If not, this Salt Stack Project 37, we have a bunch of these pull requests that had been merged to other branches, but at this point we're trying to merge them to master because we've changed how we do our development. We can go into that later, but for now, suffice it to say, these are things that need to be merged. So I went through and kind of organized these into things that may be small, medium, or potentially extremely large. So pretty much anything in here should be a good issue to take a look at. And I don't remember if this was the one. I don't think it is. Yeah, that one is, we're not going to write test for that. I want something smaller than that. Yeah, that was the one that I had suggested somebody could take a look at. But this is probably a good one. So let's, yeah, that's still still doing its thing. So let's go ahead and see about this one. So salt utils pkg rpm.py, and this is get os arch, and it looks, oh wait, no, def resolve name. Okay, so os arch is none. If, okay, yeah, so this one, if arch not in arch map versus no arch. So interesting, not in os arch. We'll double check this to see. Oh, okay, arch map or no arch. So basically what's happening here is we're saying, okay, apparently on some arches, the RPM host CPU macro doesn't match the PKG name arch, which makes sense. I've seen all kinds of ridiculous things like that before. So the code change that's going to be made here is not in arch map dot get os arch os arch. Okay, so what's happening here is it's doing a saying, okay, get me the os arch out of that arch map, or fall back to os arch. I kind of feel like it would be better have this like duplicated, but I'm not sure. I guess it depends on if that ends out being kind of a little bit wrong. But for now, we're just going to go ahead and leave this as it is and split salt. Nope, not salt. Tests, PyTests. This is in utils. Unit utils pkg test rpm.py, and it looks like that's probably not a file that exists or directory that exists. So let's go ahead and create that. Probably going to need to do a test unit utils and pkg init.py. Okay. So now it's like, why is that test file not showing up in there? because it's under the directory, which didn't exist before. So all of that. Make sure, let's actually be able to run this test. And you notice we still haven't finished installing all of our requirements over there. So, that would be the point to go get a sandwich for sure. So what we want to do is make sure that our tests are actually running. So we want tests, PyTests, unit utils pkg, test RPM. I like to limit it to just the particular test file that I'm working on, because it saves a lot of time and heartache. So there we go. We can run our test. I always like to do this first, where I just say assert false, because the number of times that I have thought that I was running the tests I was writing is a non-zero amount. And it turned out that I was just running something completely different. So yeah, that's always fun. So ideally, we would have some good test coverage for this. Now, I didn't actually do this earlier, so let's take a step back real quick and just see if we do have any existing tests for this. Where those tests would be is somewhere in tests. So find tests, and then in Salt, we actually have it configured to where the test file must match the path in Salt. Jazz says, I just learned that's the first step in TDD, test that fails. Yes, I am a huge fan of making sure my tests fail first, because yeah, it's depressing the number of times I've written a test that didn't fail first, and I'm just chugging along, and then I'm like, why doesn't anything break the way I expected it to break? And then I realize I'm testing a completely different function, or yeah, it's just a hot mess. Don't do it. Learn from my bad example. So find tests, name, test, RPM. Which only exists in the one that I created. So hooray. But that's basically the pattern is, if you have salt path to some file.py, then it will live in tests, maybe PyTests, unit, or yeah, and type path to test some file.py. So it's basically test and then file name is what you'll see. So the interesting, shoot, forgot what I was going to say there. That's still not done. So glad we had this going here. But I just got a 9-minute warning here. So let's go ahead and run a single test here. In an ideal world, we could test all of this, but all I want to do here is just do this. So test when arch is not in arch map or no arch, then name should be returned. Actually, let's change that. Arch is not an arch map, but is no arch, then name should have arch appended. And let's do import salt utils.pkg.rpm as rpm name equals actual name equals rpm name equals foo arch equals no arch, not arch equals no arch, arch equals McDonald's, and os arch equals no arch. Then we want our expected name to be foo foo.mcdonald's. And assert actual name equals expected name. And let's go ahead and run this test and see what happens. Module object, rpm dot solve name. And we have a pass. So let's go ahead and break our code here and change this to McDonald's. The reason that I like to do this, especially as I'm writing my tests, is because this helps give me assurance, right? Because before, I couldn't be sure that this piece of code here is why, I couldn't be sure that that's why things failed, right? But by changing this specifically, now I know that's why that failed. However, I just realized that arch not in OS arch and no arch. I'm pretty sure this can actually just be ignored here. And Python. And yeah, there we go. I personally like to use Nord or some other metasyntactic variable when I am testing a piece that doesn't actually matter, especially Fnord, because there's some whole backstory behind that. Just Google Fnord and you'll find it. But I like that one because it's like, look, this piece, I've got to put some value here, but legit, it's not important at all what it is. Has nothing to do with the test or anything else because it's not going to, that's not what we're testing, right? I like to do this here where I have expected name. Somebody could write something like this where you've got like name equals foo and arch equals McDonald's, and expected name equals foo.mcdonald's. I don't. Oh, I guess it would actually be name plus dot plus arch. I don't like a lot of logic in my tests. The less I have, the better. And this is actually one place I've learned that repeating yourself, at least to an extent, is actually a better idea. Because if I'm doing some logic within the test, it's possible that my logic in the test could introduce false positives. My test could pass erroneously because of some reason here. Like if this just ended out being a dot and then this ended out like that, like, I don't know, maybe, for some reason it ended out just being like this, right? For some reason, name and arch end out getting turned to empty strings. Well, my test is still going to pass, but it shouldn't have. It should have failed. Instead, if I explicitly spell out what my expected name is here, then I'm always going to see a test failure here because it's hard-coded. So that's a good thing to do. Looks like we are pretty much out of time here. Hopefully this is enough to get you started actually writing tests for SALT on your own. Highly recommend checking out this project, the project 37, if you need some starting points. There's a lot of things like this where it's pretty simple to write some tests for, and you can contribute to SALT that way. But yeah, anyways, I hope this has been informative. Hope everybody is happy, healthy, and safe. And I don't know if we have any time for questions, but
we do. I think we can go for another 3 to 5 minutes if there are questions that people have.
Right.
And so at this point, I'm happy to let people turn on their camera and mic if they want to ask the questions verbally. If you prefer to just lob them into the chat or into the Q&A tab, that's also just fine. Does anybody have additional questions or anything you want to ask Wayne about this testing workshop that he's just demonstrated?
And again, if you have, if there's questions you have that you don't have time for here, Tuesdays and Thursdays on Twitch, I'm streaming for about 2 hours, writing tests and answering questions.
Wayne, do you have that Twitch stream link you can throw into the chat here?
I can indeed.
Okay, you do have a question, Wayne.
I do. So do you have to do much mocking when writing SALT testing? So it depends is what it is. For code like this, no. And I kind of have like this default cascade. So I don't like to write mocks or do patching if I can help it. Sometimes you just can't. There's, especially if the code is a beast and like trying to refactor 600 lines in a function isn't going to happen today. Like there may not be anything you can do. You may not be able to help it. Typically, when you look at this list, most of these shouldn't have any mocks. These might have a handful, and I expect.
Boucher, you just in here chilling, man?
Tons of.
I turn on the camera and you're in here pointing at your
What's going on? Who is that? That sounds like Chunga.
Trying to check this out, make sure things are working.
I think you're in the other chat room too.
It looks good.
Am I check? Is that coming through on mine?
Reversed.
Unless
Yeah,
it's
I know
coming
you're
through on
here.
mine.
And so as I'm looking at it, it looks fantastic. Okay.
No, I muted.
Yep.
I muted. Were you still getting it?
That is that's coming through on mine. There we go.
That's super
That's
awesome.
good. Nice. Yeah. So, anyways, small probably shouldn't have any mocks. Mediums may have a few mocks. And then here I have no expectation for an upper limit of mocks. 54047 doesn't need tests. It was typo fixes. Oh yeah, I'm not sure why that is in there, other than it just needed to be merged, and that's probably why it was in small. Yeah, so I'll just have to shepherd that through the list. But yeah, anyways, yeah, so mocking is, does it have tests? Yeah, so mocking is one of those things, like, if you, the ideal world, you shouldn't have to mock really at all. And then just a quick primer on our test terms is, I tell people that, if you ask 3 developers what a unit test is, you're going to get 4 different opinions. And so defining what we say, or what we mean when we say unit test or something else, is an extremely useful exercise. So we have this documented in the documentation somewhere, but basically you have unit tests, functional tests, and integration tests, and they all exist on this spectrum, where unit tests, like, there's a line where you're like actually not testing anything except for that PyTest runs, which is not a very useful or meaningful test. And then you have unit tests, and then they start getting more and more useful as you go across the spectrum. And eventually you get over here where you've actually started a company and you are using Salt in production, which is literally the most accurate test you can have for how well Salt works in production. But that takes a while, and you don't want to do that for every test you write. So we've got the spectrum. So unit tests are tests that, like this example that we saw, they're testing an isolated piece of code that isn't touching anything else. Within Salt, there may be places that you do want to unit test, but the way that they're written, they would actually say shell out, or they would call some third-party API or something to that effect. And that's when you would use a mock, is to say unit test. But functional test, you're actually going to shell out and do those things. You're going to call an actual program. You're not going to do any like network access probably, and certainly no master to minion, like spinning those up and having that communication. And then functional tests, you'll actually spin up a master and a minion. You'll be doing everything. So typically unit tests are preferred, shouldn't have any mocks. And then things kind of change as you go over the course of things. But yeah, again, we're out of time, but definitely come by the test clinic Tuesdays and Thursdays. I have much more time to answer questions and wax on about the differences between unit, functional, and integration tests.
You can wax on and wax off about tests. Wayne, thank you so much for this presentation. Thank you, everybody, for being here, for participating. Any questions, feel free to reach out directly to me or Wayne or anybody else that's on Salt Project. And we'll let everyone out so that you can have a break before your next session. And thank you all. Have a great rest of SaltConf.